Okay, so let's talk about our answers as we are in lesson number 14, the typical 2 videos. Hopefully it'll only take 2 of the work that we need to do for this presentation on this particular day. So first one up, solve for x and y, and then a simplify. So let's have you just, you can do stop and start, check your answers as you scroll through. Should you have any questions, you can reach out to me or a friend or a buddy and we can go over it. Okay, so these have been homework 13 answers, but the newer material on homework 13 involved question 14, A, B, and C. It's the solution to a quadratic equation. And just remember, the whole idea is to make sure we get everything on one side, and then we factor and solve. Once again, get everything on one side, factor and solve. So that's the answers to homework number 13. Now let's take a look at the pregame stretch for number 14, which of course you can download off Moodle, or you can just do stop and start with this and get all the questions answered. I'll show you the answers to them in just a couple of minutes. Okay, so, and now finally the answers to the pregame stretch. Okay. Again, any questions, you can reach out to me via email, another person in the class, rewatch the video, whichever you prefer. Of course, in case someone's new listening, you should be stopping the video, checking the answers, and then when you're done checking the ones in question, you resume the video. And remember, with your quadratic equations beginning at number 21, that you get everything equal to 0. Get it all on one side. Okay? And that's true regardless of whether you're doing a solving quadratic equation by factoring or by the quadratic formula. Okay, so that's all of our preliminary sort of stuff. Now, let's get into our PowerPoint presentation for the day. And we'll start off on the beginning of it, which, okay. So, quadratic equations, lesson 14. What is lesson 14 going to be all about? Well, let's see. As usual, we'll do homework review, which we did, and the pregame stretch, which we did. We are now on recent work recap. All right. Remember to do stop and start. Okay, so on the first one, it's just a pretty straightforward simplifying by combining like terms type of question. Altogether, I have 5x squared and 4x squared makes 9x squared. Negative 2x and negative 9x make negative 11x. And negative 7 and positive 4 make negative 3. Now, second one, upper right-hand corner. We're going to distribute that negative to everything in the package or parentheses or group that follows it. So my first step is to say, okay, I still got my 5x squared minus 2x minus 7, but then I negate, because that's what the negative sign does, everything in the parentheses. So the 4x squared becomes negative, the 9x becomes positive, and the 4 becomes negative. Now I combine like terms. 5x squared and negative 4x squared is 1x squared, negative 2x and 9x is 7x, and negative 7 and negative 4 is negative 11. Okay, lower left, let's distribute the 2, distribute a positive 3, so we're not changing any signs, and then combine like terms. So 2x squared plus 10x minus 10 plus 3x squared minus 3x minus 21. 2x squared and 3x squared make 5x squared. 10x minus 3x is 7x, and negative 10 and negative 21 is negative 31. And last but not least, we're going to distribute again a 2 and a 3, but this time the 3 is going to be negative. So distributing the 2 would give me 14x squared plus 14x minus 10. Distributing a negative 3, I have to multiply by 3 and negate everything. So that's negative 3x squared plus 3x plus 21. Adding them all up, 14x squareds and negative 3x squareds is 11x squareds. 14x and 3x makes 17x, and negative 10 and 21 makes 11. Okay. A little more review. Let's do a pair of double distributes and a triple distribute. Go ahead, and you can do stop and start. Okay, so double distributing the first one, distributing the x to both terms, then the 8, I get x squared minus 4x, and then 8x minus 32. On the upper right, I'm going to get 15x squared. Oh, forgot, I can combine all the x's in the middle there to plus 4x. On the right side, 3x times 5x is 15x squared, 3x times 9 is 27x positive. Negative 7 times 5x is negative 35x, and negative 7 times 9 is negative 63. Remember, you're always peeking in front to see what you could come up with here. Okay, so negative 7 times 5x is negative 35x, and negative 7 times 9 is negative 63. Don't forget that 7 is negative. Combining the like terms in the middle gives me a negative 8x. Now, triple distribute. The x times each one of them will be x to the third minus 11x squared minus 3x. And then distributing the 3 gives me 3x squared minus 33x minus 9. Combining like terms, well, the x cubed and the negative 9 are sole terms. There's nothing to combine with them. But negative 11x squared and 3x squared makes negative 8x squared. And negative 3x and negative 33x makes negative 36x. Okay. All right, let's do some reverse engineering, aka factoring, using the greatest common factor. Go ahead. Okay. Okay, so in the first case, we're going to factor out a 15. That leaves 15 times n minus 3. In number 2, the greatest common factor is a 4, so let's factor that out. That leaves us with 3g plus 7. Number 3, the greatest common factor is a 2. That leaves me with 5x minus 9. Number 4, they don't all share a's in common, so we can't factor out any a's, but they do share a 5. So that would be a squared minus 9a plus 2. And of course, we distribute back. 5 times a squared is 5a squared. 5 times negative 9a is negative 45a. And 5 times 2 is 10. Now, things get a little bit dicier when we take a look at number 5, because we need to both factor out a numerical part of a greatest common factor and a variable part. So we factor out the 3 and the a. And when I do that, 9 divided by 3 is 3, and a squared means aa. So if I take one of them out, there's one remaining. And to check back, 3a times 3a is 9a squared, and 3a times 7 is 21a. Number 6, we're going to factor out a 5 and an a, similar reasoning. 5a times a is 5a squared, 5a times negative 2 is negative 10a. So that is our warming up with factoring with the greatest common factor. Now let's just do a couple of quick double distributes as we set up a key understanding. Go ahead. Okay, so number one, double distributing. I get x times x is x squared, x times negative 5 is negative 5x's, 4 times x is 4x's, and 4 times negative 5 is negative 20. Combining like terms in the middle, I get a negative x, so it's x squared minus x minus 20. And it is very much worth noting here that 4 times negative 5 is negative 20, and 4 plus negative 5 is negative 1. And that's the foundation of the AM method. Number two, 2x times x is 2x squared, 2x times 2 is 4x's, 7 times x is 7x's, and 7 times 2 is 14. Yes, 7 times 2 is 14, but 7 plus 2 is not 11. And that brings us to a stark reality. The stark reality is that this AM method, or the calculator method that we have taught and discussed at length for the last, this is the 4th day of it, only works when the lead coefficient is a 1 in front of the x squared, like on example 1. If you get like in example 2 with any number other than 1 in front of the x squared, then you cannot use the AM method. And we have to go, to plan A and plan B. Okay? These techniques do not work if the lead coefficient is not 1. Okay, so let's see you factor numbers 8 and 9. Go ahead. Okay, we will note that the lead coefficient in both of these is 1, so we can use the AM or calculator techniques. In this case, we're going to multiply out to 70 and add up to negative 17. Those factors would be negative 10 and negative 7. So that means I get x minus 10 and x minus 7. And let's multiply back. X times x is x squared, x times negative 7 is negative 7x. Negative 10 times x is negative 10x, negative 7x, and negative 10x is negative 17x. And negative 10 times negative 7 is 70. Now, if I use the calculator, I always start with the last number divided by x. Then on y2, I put the same exact thing, plus x. Make sure whatever you put in y1 is in parentheses, or this will fail. And then I look in the last column for a negative 17, and then I look back at the 2 previous rows, I will see negative 10 and negative 7. Number 9, I need to multiply out to negative 21, add up to 4. 2 numbers that look, I wrote multiply out to 21. It should say negative 21. Sorry about that. I check it out, and I come up with 7 and negative 3. That means I get x plus 7 and x minus 3 as the factors. Let's just double check. X times x is x squared, x times negative 3 is negative 3x, 7 times x is 7x. Adding up 7x and negative 3x, I get 4x, and 7 times negative 3 is negative 21. If I chose to use the calculator approach, always the last number, negative 21 divided by x. Really don't know why I missed it on that first one. And then make sure it's in parentheses, plus x. In the last column, look for a 4. The 2 previous columns will say 7 and negative 3. So that's factoring with the lead coefficient of 1. It's our 3rd day of doing this, or I should say we finished 3 days of doing this. So I think we should be pretty comfortable with this, factoring with the lead coefficient. Other than 1, however, is not quite so simple. So let's finish this one up. Go ahead. Okay, so on the first one, I look for a greatest common factor. I cannot find one, so I go to plan B. I multiply the last term by the leading coefficient. That works out to be 18. So I get x squared plus 19x plus 18. Factoring that, I get x plus 1 times x plus 18. But don't forget, I changed the question, so now I have to balance that out by dividing back. X plus a half. Basically, since I multiplied by a 2 up top, I divide by a 2 to balance it out. Elementary school trick on the left because it can't be simplified. And on the right, 18 over 2 is 9. So that makes 2x plus 1 times x plus 9. I don't know why it says, x plus 2. It must have been left there from the previous one. It should be 2x plus 1 times x plus 9. Okay, now let's take a look at The middle one, there is no greatest common factor, so I'm going to multiply the last term by 3. That gives me x squared minus x minus 12. I factor that. I get x minus 4 times x plus 3. I then, since I multiplied by 3, I have to divide back by 3 and balance it out. So x minus 4 thirds plus times x plus 3 over 3. 3 over 3 reduces to 1, and elementary school trick, 3x minus 4. If I check back, it will definitely work. 3x times x is 3x squared. 3x times 1 is 3x. Negative 4 times x is negative 4x. Add that up, I get negative x. And 3x times 1, negative 4 times 1 is negative 4. So it works. You may sense a little bit of speed added on my part because I am supposed to take my blood pressure meds in a couple of minutes, and my phone is going to make an alarm. So we'll see what happens. Number 10, I look for a greatest common factor. Again, I see none. So I go to plan B, which is to multiply the last one by the leading coefficient. So I take the 5 in front, multiply it by the negative 4, and I get x squared plus 8x minus 20. Factor that. X plus 20, it should be x plus 10x minus 2. There's a little bit of an error there. Okay, let me just correct this real quick because well, you know what? I won't, because I'm willing to bet the next step does it correctly. It should be x plus 10x minus 2, not x plus 20. Balance it out by dividing back, and I did not do that, so let me correct it now. Okay, so hopefully I don't need to swap displays on this. Today in class, I didn't need to swap any displays. I corrected those two things. Okay, so here we go. This should be x plus 10 times x minus 2. Then, because I multiplied the 5 by the last term, I've got to come back in and divide by that 5. And that reduces 10 over 5 is 2, and elementary school trick on the other one. That gives me 5x minus 2. So x plus 2 times 5x minus 2. Let's check back to make sure that I don't have another careless mistake in there somewhere. X times 5x is 5x squared. X times negative 2 is negative 2x. 2 times 5x is 10x. 5. Let me try this again here. Oh, okay, there we go. 2 times 5x is 10x, and negative 2 times x is negative 2x. 10x and negative 2x do make 8x. Somehow I got lost in track there, and 2 times negative 2 is negative 4. So that checks absolutely perfectly. Okay. Now, more lead coefficients other than 1. Go ahead, try these 3. Remember, look for plan A, then look for plan B. Okay, So on number 1, we know that means 2n squared minus 10n. We went over one similar to that the other day. This does share a 2 in common, so let's factor it out. 2 times x squared minus 5x plus 4. Factor the x squared minus 5x plus 4. That's x minus 1 times x minus 4. Now, factor number 12, which is they share a 2 in common as well. This comment about don't forget the 2. So many times students just write x minus 1, x minus 4 because they're used to it. But 2 is also a factor. It was factored out first, so don't forget that. And then the next one, factor out the 2 they share in common. That makes it plan A. X squared plus 3x minus 40. We'll just factor that guy. That gives me x plus 8 times x minus 5. Of course, the 2 in front, don't forget about that guy. And just to do this one, multiplying back, x squared minus 5x plus 8x is 3x, which is what you want. 8 times negative 5 is negative 40. And then if we double everything, we're going to get to 2x squared minus 6x minus 80. So that works perfectly. So we did check back, and we did not forget the 2. Now for number 13, they don't share a common factor. So that's when we go back to plan B as in the preceding slide, and we multiply the last term by the leading coefficient, which means I multiply 4 by the negative 3. That gives me x squared minus x minus 12. I factor that, and I get x plus 3x minus 4. Now you got to remember, I have to balance this out because I changed the question. So I balance it out by dividing back in by that 4. First one will be elementary school trick because that cannot be reduced. Second one is x minus 1. So that's 4x plus 3 times x minus 1. Just let's check back. 4x times x is 4x squared. 4x times negative 1 is negative 4x's. 3 times x is 3x's. That adds up to a negative x. And 3 times negative 1 is negative 3. That, folks, is a great summary of everything that we have done so far.